We are going to look at two more ways of viewing a system of linear equations. Each of these views brings about convenience depending on the context. The first is what is commonly known as the column view. Say you are given the system Ax equal to b, where A is the matrix given by 1, 2, 3 in the first row and 4, 5, 6 in the second row. X is a tuple of three variables x1, x2, and x3, and b is 7, 8, and 9. As you may recall, the left-hand side in Ax equal to b is simply a shorthand for writing a two-tuple. So the first entry of this two-tuple is given by 1 times x1 plus 2 times x2 plus 3 times x3. And for the second entry is given by 4 times x1 plus 5 times x2 plus 6 times x3. Now we're going to write this differently, and we are going to use the following convention. Given an m tuple T1 up to Tm, where T1 up to Tm are elements from some structure on which addition and multiplication is defined, and another element alpha from the same structure, we write alpha times this m tuple. So this is m tuple is defined as this m tuple. So you multiply each entry by alpha. So with this convention, I can rewrite this as the following. What we have here is what is known as a linear combination of the tuples 1, 4, 2, 5, and 3, 6. With this, we can interpret Ax equal to b as follows. Basically, we're asking whether or not you can write b as a linear combination of the columns of A. So in general, if A is a matrix given by the columns A1 up to AN, where AI is the ith column of A, and X is x1 up to xn, then Ax is simply x1 A1 plus x2 A2, and so on all the way up to xn An. So if you have Ax equal to b, then we are asking if b can be written as a linear combination of the columns of A. So solving for Ax equal to b means finding a linear combination of the columns of A that will give you b. So this is the first view in this two-part series. The second view is that of a linear transformation, and we'll be looking at this in the next video.